Hello, so today we are going to do this problem called passable Bipartition, which is part of Leetcode Daily Challenge. So the problem says we get a group of n people that are labeled from 1 to n, and we want to split them into two groups of any size, right? And each person may dislikes another one. And so if one person dislikes another, they should not go into the same group, right? They should be in separate groups. And we have only two groups. That's important. And we want to return an integer n. So given that integer n and the dislikes, which tell us if A dislikes B, we want to return true if it's possible to split n people to two groups, maintaining the condition that no two people that one of them dislike the other are in the same group, right? So that's the idea. Now, how do we solve it? So if you think about this, actually, this is exactly the definition of a graph being bipartite, because bipartite means you can divide the graph into two groups, right? Such that the only edges are the edges between the groups, right? There are no edges in the same group, right? And that's exactly what we want. We want each group to have no dislikes, which means if we take the dislikes as the definition of our edge between two nodes, we'll end up with, we can just check if the graph is bipartite. If it is bipartite, then we can divide into two groups where there are no edges, right? So there is a Leetcode bipartite graph that we can reference. Bipartite graph. Let me just hide this. Yeah. So basically here it says, let me see. Yeah. So a graph is bipartite if the nodes can be partitioned into two independent sets. You can think of this as groups, such that every edge in the graph connects only the nodes in group A and group B, right? So that's exactly what we want here. We want two groups A and B, but we want the edges to be only from group A to group B. And the edges, we can represent them using this dislikes, right? So that's the idea. Okay, so how do we check that the two graphs are, that the graph is bipartite? So what we will do is just have first our nodes, a graph where we just take the dislike array, and if there is maybe A and B connected, let's say this is A and B, basically A dislikes B, then we'll add an edge between A and B. Now the question becomes, should this be directed edge, or should it be both A to B and B to A, right? Well, depend on the problem. The problem says that we want, if any one dislike the other, we don't want them in the same group, right? So we do want to represent the edge bidirectional, because if we make it just directional, right, then we may miss, right? Then we may try to group them because there is no edge between B and A, right? So we need to make it bidirectional. So that's the first thing. Now the question is, how do we check bipartite, right? Okay, so how do we check if a graph is bipartite? It's easier with coloring, right? Because what we can do is, let's say we have maybe the first example, right, where n equal to 4. So we have 1 is connected to 2, and we have 1 is connected to 3, and then we have 2 is connected to 4, like this, okay? So this is, you can see here, this is clearly a bipartite, because we can divide into this group, and we will get the edges are only between the two groups. There is no edge between 1 and 4, and no edge between 2 and 3. But how do we do that? Well, when we can just traverse with the DFS, right, and color each nodes that are adjacent to each other, that have an edge between them, color them with a different color, right? So what this would mean is basically maybe color one with blue and the other one with, let's say, black, right? Whenever we have two that are connected, color one with blue and the other with black, maybe or whatever colors we want, right? If we ever get two nodes that are the same color, what does that mean? So that means that if we get two nodes that have an edge between them that have the same color, that means this is the second, we visited this before. We visited this node before, and we ended up coloring it black because it was connected to another, blue because it was connected to another one. Let's say maybe like this, that is black. Okay? So what does this tell us? This tells us that this one is in a different set than this one. Right? But this one has to be in the same set because there was another black that was connected to it. Right? Okay, so what this tells us is actually, so these has to be in different groups, and these has to be in different groups as well. But that means we can't do two groups anymore, right? So I hope that makes sense, but that's the idea. And so how do we color while doing DFS? We can just use a map using the label of the node and just mark the color. And to represent blue and black, we can just maybe say blue is 0 and then black is 1, and then we assign, right? And if ever we find a node that we already visited, right, that is the same color, then we return false because the graph can't be bipartite, because this means we can't do two groups. Okay, so that's the idea. Now let's implement it. Okay, so let's implement the solution we just saw in the overview. I would recommend also just taking a look at this problem. I will link a video for it. It's pretty similar, right? So the first thing we need to do is definitely create our graph, right? So that would be using dislike. So this is going to be collections.default dictionary on list. And then we are going to go through the nodes in dislikes, right? We said that we want the graph to be bidirectional, right? So each node is going to have the other as a neighbor. And so similarly, we have U and we have V here, right? And now we need our DFS on I. And then we are going to call DFS. So we need our colors as well. And we'll call DFS in case there are multiple connected components, right? We need to check, right? So we'll call it on all the nodes. And the problem says the nodes are labeled from 1 to n. So we need 1 to n, and in Python there needs to be +1 here. Okay, and only if a node is not visited that we need to do DFS on it, right? And let's say DFS here just checks, our DFS checks if bipartite, okay? And so if it says not bipartite, we want to return false. Now, if we go through all of them and we didn't find that they are not bipartite, so we weren't able to find two nodes that are connected with an edge that are the same color, then we want to return true because the graph is bipartite in that case. Now, our DFS needs to first be just like a normal DFS. We need to go through the neighbors, right? However, if a node is already visited, we want to check its color, because if its color is the same as our node color, then that means we are in the problem we mentioned, which is two nodes that are connected, but they have already the same color, right? And so we want to check if the colors of this neighbor, of the node and its neighbors are equal. That means we can't, this is not bipartite, so we want to return false, right? Because they have the same color, that means this one was already colored by another neighbor with blue, right? Which means its neighbor is black. It has another neighbor black, but then it has this new neighbor node that is blue, right? So it's no longer two groups that are connected with edges. So we're going to return false here. So this is not a node, actually. This is I. Let's call it I. And now otherwise, if it's not visited, we just want to mark it with the opposite color, right? For each node, we want to mark it with the opposite color. So we said we can just use 0 for blue, right? 0 for blue and 1 for black. So to get blue from black, so if it's blue, we can just use minus the color of the neighbor, right? Because if it is 0, then we would get 1, which is black. If it's 1, we'll get 0, which is blue. So that will always give us the opposite value, right? So in that case, we want to assign the opposite value to the opposite color to the neighbor, and that's what we do with this. And then we are going to visit neighbor. And if ever the neighbor reports that it found a contradiction from here, not allowing us to have a bipartite graph, then we want to return false. And then if we go through all the neighbors and we didn't find a condition that tells us the graph is not bipartite, we want to return true, because at least from the connected component of this node, it's bipartite, right? And so that's pretty much it. Now let's run this. Okay, so we said, yeah, we forgot to do one thing here. When we start out from a node, we need to color it with one color to get the traversal started here. So let's just start out with blue. Then it will color its neighbor with black. Okay, so that looks good. Let's submit. And that passes test cases, right? Now, one thing we want to do maybe is you could try to here just check if instead of constructing the graph, you could try to here just get it from the dislikes, but it's a list and we have to search the list, so I don't recommend that. But yeah, this is pretty much it. You can use DFS and using this coloring trick to find if the graph is bipartite. Yeah, so that's pretty much it for today's problem. Please like and subscribe, and see you on the next one. Bye.